Auto scaling is a funny thing. We have a couple of different methods of doing this. The standard cluster autoscaler, which is pretty relevant in every Kubernetes implementation because it is part of the Kubernetes SIG. It does have its own dedicated maintainers and projects, etc. And it's used across any Kubernetes environment, EKS, AKS, GKE, on-prem, etc. Okay. So in the cloud, it's going to look a little something like this. When you add a node group, we'll just give it whatever name. And we're going to go to next. And down here is where you have your scaling configuration. So really the idea is this. You're going to specify your desired size. You're going to specify the minimum size. You're going to specify the maximum size. So right off the bat, it's kind of manual in the sense of this autoscaler because you have to set the max, you set the minimum, etc. Right? So if we move more towards the code enablement of this, okay, we can do something like this where we have this code configuration that what we'll do is we'll specify the cluster name and the node group, and then we'll specify this command update node group config. And what it's going to do is we're going to specify our min size, max size, and desired size, right? So min size 2, maybe max size 5, desired size 3, okay? So this is a little bit better from an automation perspective, but take this into account. Let's say you have like 3 to 4 or whatever busy times per week. You know, maybe your busy times are, at 9 a.m. and at 1 p.m. or something like that. Whatever the case may be, you have to just manually always kind of run this configuration here because your desired size for a busy time is going to be less prevalent than 1 o'clock in the morning when no users are using your configuration. So this, although we have the ability to set up the cluster autoscaler and it makes things a little bit easier, well, it makes things a lot easier versus like having to manually add nodes and take out nodes, etc. Right? We run this command and boom, now we have 2 here, but it's going to take a little bit of time and, upgrade itself. And as we can see, now this one just popped up, not ready yet, not ready yet, not ready yet. We'll go ahead and give this a little bit of time here. Okay, so now it's ready. So about 11 seconds, but that was, after the worker node was created. Now, when I ran this command, I would say all said and done, maybe 30 to 45 seconds. And that's kind of a long time to get everything up and running. However, when we're using something like CastAI, here's the thing. In CastAI, there's this option called autoscaler settings, okay? So you go in here and you choose the unscheduled pod policy, automatically adjust the size of a Kubernetes cluster so that all pods have a place to run. And then the node deletion policy, this policy will automatically remove nodes from your cluster when they no longer have scheduled workloads, okay? And then you have a bunch of different other settings here. But the point being is this. All of that manual configuration that I just showed via either the UI or via the CLI, that's all taken out now. I don't have to do any of that. I literally just have to enable it on CastAI and that's it. I don't have to do anything else. And then from a savings perspective, like we saw, I can click the rebalance button here. I can click rebalance and that's it. That's all I have to do. So not only is it a little bit faster from a configuration perspective, but once you click the button, that's it. And by the way, this is the full rebalancer and it's taking just as much time as just the standard, scheduling up, scheduling down. So this process is going to be much faster from an overall configuration perspective for 2 reasons. Number 1, the rebalancer works a little bit faster. Number 2, I don't have to do anything. Once this rebalancer is said and done and the auto scaling is turned on, right? I can have these node templates here. I can add a template in and I can specify what I want the environment to look like from a node configuration perspective, the processor architecture, GPUs enabled, the various instances that I want to be able to run, etc. once I set up all of this configuration and it's connected to my EKS cluster, I don't have to do anything else. It does it for me automatically. Like that's it. I don't have to run any more commands. I don't have to do any configurations. No, once I just do these couple of things that I just showed, that's it. Now I'm hands off. It's going up 10 worker nodes. It's coming down to 1. It's doing all of this based on load, and I don't have to do anything about it. So the whole idea from a performance and benchmarking perspective of, which method is quicker, Cast is definitely going to give you the quicker option for 2 reasons. Number 1, you don't have to do anything. It does it for you. So if time is money, and if you're paying people and people are taking time to do it, you're saving a ton of money. And the scaling up and scaling down is going to be much faster once the rebalancer is fully configured here, because this is literally going through and rebalancing and configuring for the first time my entire cluster. All right. And just like that, we can see that that was created, and we can see the overall cost savings here. So even outside of a performance benchmarking perspective, you're not just getting the auto scaling, you're saving money.